The airline company Air Ilan schedules a flight every day from Dublin to Amsterdam. The probability that the flight to Amsterdam is late is 0.03. Calculate the probability that for 50 such flights to Amsterdam, no flights are late. Well, we're dealing with 50 Bernoulli trials, where Bernoulli trial is a flight to Amsterdam. There are two events in each Bernoulli trial. The events, the plane is late and the plane is not late, have probabilities 0.03 and 1 minus 0.03 respectively. So 1 minus 0.03 is 0.97. So I will let the letter capital F stand for the random variable which takes on the number of flights that are late out of 50 flights. So we know from a previous video that this is a binomial random variable with parameters n and p, where n in this case is 50, p, the probability of a flight being late, is 0.03. We know that the probability that the random variable f takes on a particular value, little f, is given by ncf p to the f times 1 minus p to the n minus f. So for this question we want a probability that capital F equals 0. So remember, big F, the random variable, stands for the number of flights that are late. So big F takes on the value 0, 1, 2, 3, 4 up as far as 50. So n is 50, little f is 0. Sometimes you might see the little r here in place of little f. Doesn't matter what notation you use, of course, it's all the same. So anyway, we put 0 in for little f. P, the probability that a flight is late, is 0.03. 1 minus p is 0.97. N minus f is 50 minus 0, which is 50. So basically, our calculation boils down to 0.97 to the power of 50. This is 1 and this is 1. So we have 0.97 to the power of 50. So to 3 decimal places, I'll write it down to 4 decimal places. We get 0.2181. So even if we know nothing about the binomial distribution, we could just calculate this quantity here. We are dealing with 50 independent events, where each event has probability 0.97 of occurring. So since they're independent, we multiply 0.97 50 times by itself. In the next question, we want the probability that at most 2 flights are late. So here we want the probability that f equals 0, that means no flights are late, or f equals 1, which means that exactly 1 flight out of the 50 flights is late, or f equals 2, which means exactly 2 flights out of the 50 flights are late. These three events, f equals 0, f equals 1 and f equals 2, are mutually exclusive. If exactly no flights are late, then we can't have exactly 1 flight being late, and vice versa. So these three events, and similarly for this event, so these three events exclude each other. So by the OR rule, we just add the probabilities together. That the probability is f equals 0 has already been calculated. To 4 decimal places, it's 0.281. Now what about the probability that f equals 1? Well, we just apply our binomial distribution formula, where little n is 50, little f, or little r if you want to call it, is 1. So we 50c1 times p, the probability that a flight is late, is 0.03, so we just want one of the flights to be late, and we want the rest of them to not be late. So the probability a flight is not late is 1 minus 0.03, 0.97, and we have 49 flights remaining. Of course, these two numbers, 49 and 1, must add to 50. And over here, we have 50c2. This time little f, or r, is 2. Probability again is 0.03 to the power of 2. We want 2 flights to be late, and we want the remaining flights to not be late. We want exactly 2 flights to be late in this probability. So we have to have 48 here. So we want 48 flights to be on time. So we multiply these events because they're all independent, and then multiply by the number of ways that 2 flights can be late. To 4 decimal places, we get 0.8108. Now in part 3 we want the probability that 2 or more flights are late. Well, this means the probability that big F equals 2, or F equals 3, or F equals 4, or dot dot dot, as far as the probability that F equals 50. That means all flights are late. So we could calculate all of these probabilities directly, and then by the OR rule we sum all the probabilities. But of course we have a lot of sums to do here. We have 49 of them. So to make life much easier, we use the fact that all the probabilities that F can take on, well, the probabilities for all the values that F takes on from 0 to 50 must sum to 1. So F has to be one of the values 0 or 1 or 2 or 3 or 4 or 5 all the way up to 50. It's a certainty that F must be one of those values. It's actually 51 values, including 0. So that's a certainty. So that the sum of all those probabilities is 1. So if that's the case, then if we want to find this probability that F equals 2 as far as 50, we take 1, the sum of all the probabilities, and subtract off the probabilities that F equals 0 or 1 or 2. And we've already calculated this thing in the previous part. We got 0.8108. We get 0.1892.